Imagine harnessing the power of the sun not just during the day, but at night. Thanks to a groundbreaking scientific breakthrough in Australia, this concept could soon become a reality. Overview of solar energy's challenge. For decades, solar energy has been hailed as one of the most promising sources of clean, renewable power. However, there's one major limitation that has always held it back. The sun doesn't shine at night. Traditional solar panels rely on sunlight to generate electricity, meaning they can only work during daylight hours. Once the sun sets, energy production stops, and we're left dependent on stored energy in batteries or backup power sources like fossil fuels. This presents a significant challenge to achieving a reliable, round-the-clock renewable energy supply. Now, imagine if we could extend the benefits of solar energy beyond the confines of daylight. That's where nighttime solar technology comes into play, a revolutionary concept that could allow us to generate electricity even after the sun has set. Purpose of the video. In this video, we'll take a deep dive into how scientists are turning the once theoretical idea of nighttime solar power into a tangible reality. We'll explore the cutting-edge science behind it, how this innovative technology works, and what it could mean for the future of energy. Get ready to see how this breakthrough could transform the way we think about solar power, day and night. The breakthrough from Australia. Research from UNSW. The pioneering team behind this breakthrough comes from the University of New South Wales, UNSW, one of the world's leading research institutions in renewable energy technology. This group of researchers, led by Professor Ned Ekins-Daucus, has been at the forefront of innovation, pushing the boundaries of what we thought was possible in solar power. For the first time, they've demonstrated that it's possible to generate electricity at night, not from sunlight, but from the Earth's radiant heat. This new technology leverages a device called a thermoradiative diode, which captures the infrared radiation that the Earth naturally emits after sunset. As the Earth cools from the heat it absorbs during the day, it radiates that heat back into space in the form of infrared light. The UNSW team figured out how to capture a small portion of that infrared light and convert it into electricity, providing a potential new source of energy long after the sun has set. Current limitations. Although this discovery is remarkable, it's important to recognize that the technology is still in its early stages. Currently, the amount of electricity generated by the thermoradiative diode is about 1/100,000th of what a traditional solar panel produces during the day. While that might seem insignificant now, this is a proof of concept, the same place traditional solar cells started decades ago. In fact, if we look back to the 1950s, when the first silicon solar cells were created, they were only about 2% efficient. Today, commercial solar panels are more than 20% efficient, and power homes, businesses, and even space stations. Like those early solar cells, the UNSW team's nighttime solar technology has tremendous room for growth. Over time, with further research and development, we could see significant improvements in efficiency and power output, making it a viable addition to our renewable energy solutions in the future. The potential of nighttime solar power. Scaling the technology. The true potential of nighttime solar power lies in its ability to scale. While it's currently in its infancy, this technology has the promise to follow a similar path to silicon solar cells, which started as a laboratory experiment in the 1950s. At that time, the first solar cells were just 2% efficient, producing barely enough power for small devices. But over the decades, through continued research and innovation, these cells became much more efficient and cost-effective. Today, they are a major source of clean energy, powering everything from homes and businesses to satellites in space. The thermoradiative diode technology behind nighttime solar power could follow this same trajectory. If efficiency can be improved and the technology scaled up, it could become a game changer for global energy production. Imagine a future where we can harness energy from the sun during the day and continue generating power from the Earth's radiant heat at night. This breakthrough could move us one step closer to achieving a truly 24/7 renewable energy supply. Energy grid stability. One of the biggest challenges with renewable energy, particularly solar and wind power, is the issue of intermittency. Power generation fluctuates depending on weather conditions and the time of day. Nighttime solar power could provide a solution to this by filling in the gaps left by traditional solar PV systems. Currently, when the sun sets, solar power generation stops, forcing energy grids to rely on batteries or fossil fuel-powered plants to meet demand. With the ability to generate power after sunset, this new technology could provide a steady, consistent source of electricity, significantly reducing our dependence on batteries or non-renewable energy sources. By complementing existing solar and wind power systems, nighttime solar could help stabilize the energy grid and ensure a more continuous and reliable supply of renewable energy. This could be particularly beneficial for regions that experience frequent power shortages or where energy storage systems are expensive or limited. Applications beyond the grid. Beyond large-scale energy production, nighttime solar power has exciting potential for smaller, more personal applications. The thermoradiative diode technology could be used to harvest energy from body heat, offering a new way to power bionic devices like artificial hearts. Current bionic devices often rely on batteries that need frequent recharging or replacement. With this new technology, devices could potentially be powered continuously by the wearer's own body heat, reducing the need for external power sources and improving the quality of life for individuals who depend on these medical devices. Another fascinating application is in small consumer electronics. Imagine a wristwatch or fitness tracker powered entirely by your body heat, eliminating the need for batteries altogether. This could lead to a new generation of wearable technology that is more sustainable and convenient for consumers. Whether it's powering medical devices or everyday gadgets, the potential uses for nighttime solar power extend far beyond the grid, opening the door to a host of innovative solutions for energy generation. Space applications, spacecraft, and satellites. The potential of nighttime solar technology doesn't stop on Earth. It could also have a profound impact on space missions. In low Earth orbit, where satellites and spacecraft like the International Space Station reside, each day lasts just 90 minutes, split equally between daylight and darkness. During periods of darkness, these spacecraft rely heavily on batteries to maintain power. However, thermoradiative diodes could change that by allowing spacecraft to generate electricity even in the absence of sunlight. By capturing the radiant heat that the Earth emits at night, thermoradiative diodes could provide spacecraft with a new power source during eclipse periods, reducing the need for heavy and expensive battery storage. This technology would ensure that essential systems on board spacecraft continue running smoothly through nighttime periods in orbit, improving mission reliability and extending the operational life of satellites and space stations. Historical parallels. The development of nighttime solar technology is reminiscent of the early days of silicon solar cells, which were first developed for use in space. In 1958, the first solar-powered satellite, Vanguard 1, demonstrated how solar cells could be used to power spacecraft in orbit. That breakthrough paved the way for solar energy's widespread use on Earth. Today, silicon solar cells are a crucial part of our renewable energy infrastructure, powering homes, businesses, and even space missions. Thermoradiative diodes could follow a similar path, just as silicon solar cells went from space experiments To becoming a global energy solution, nighttime solar technology could start by powering spacecraft in orbit before being scaled for broader use on Earth. By bridging the gap between day and night, both in space and on Earth, this new technology has the potential to revolutionize the way we think about energy generation across the universe. Summarize key points. In summary, nighttime solar technology represents a remarkable breakthrough in renewable energy, allowing us to harness the Earth's radiant heat to generate electricity after sunset. By utilizing thermoradiative diodes, this innovative approach addresses one of the most significant challenges of solar energy: the inability to produce power during the night. The potential applications of this technology are vast, not only for providing continuous energy on Earth, but also for powering spacecraft in the depths of space. As this technology matures, it could transform the renewable energy landscape, paving the way for a more reliable and sustainable energy future. A vision for the future. As we look ahead, it's exciting to consider how nighttime solar power may become a key player in solving one of the greatest energy challenges we face: providing clean, reliable power day and night. With ongoing research and development, we stand on the brink of a new era in energy generation, where our reliance on fossil fuels diminishes and renewable sources can fulfill our needs around the clock. I encourage you to stay informed about advancements in renewable energy technologies like nighttime solar power. Your awareness and support for sustainable innovations can help drive the change toward a cleaner, more sustainable future. Together, we can advocate for a world powered by renewable energy, ensuring that future generations enjoy a healthier planet. Thank you for watching, and let's continue to explore the exciting possibilities of clean energy.